Welcome to the 13th video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will discuss the equations of motion and how to use them for problem solving. There are 5 equations of motion that can be helpful for us, but before seeing them, let's discuss under which conditions we can use them. First, the motion has to be straight line, so one-dimensional. Second, the acceleration needs to be constant. We will be able to deal with problems involving different accelerations at different times, but then we will have to treat these parts separately. This means that the velocity may change, but at a steady rate. And in the problem, the motion should be described using some of the following parameters: delta x, so the change in displacement, the initial velocity, the final velocity, the acceleration, and the time. Let's see the first equation. The final velocity is the initial velocity plus the acceleration multiplied by the time elapsed. This equation shows the linear relation between velocity and time given a constant acceleration. It is advantageous to use it when you know the time. You can associate the velocity-time graph with this, where a constant acceleration will lead to a straight line. For example, in this graph, we could take this first segment from 0 to 3 seconds. Reading the initial and the final velocities, as well as the time from the graph, you could use this equation to calculate the acceleration. The next 2 equations relate to the displacement. In both of them, you can see that the displacement is expressed as the sum of a linear term and the acceleration term. We are expressing the same idea using either the initial or the final velocity. If we use the initial velocity, we have to add the acceleration term. If we use the final velocity, we have to subtract this term. The fourth equation, this one, is great for problems where the time is unknown. For example, when you have a car that is braking over a distance, but you don't know how much time has elapsed. The equation describes that the square of the final velocity is the square of the initial velocity plus 2 times the acceleration multiplied by the distance. As you will see in your later studies, this expression is also closely related to energy. The final, 5th equation of motion is related to the average velocity. It gives the displacement as the average velocity multiplied by the time. It is very important that this only works for constant acceleration. This formula is a fast and easy way to get the displacement if you know the initial and the final velocities. This slide shows a summary of the 5 equations of motion and when to use each of them. If you know the time, you can use the first one. If not, but you know the displacement, you can use the 4th equation. The second and the third are useful if you know either the initial or the final velocity, plus the acceleration and the time. While the last one is great if you know both of the velocities. Finally, let's go through a problem-solving strategy for these types of kinematics problems. The first step is to draw the situation and choose the positive direction. With this, you can be sure that you understand exactly what is going on in the problem. If the problem is 2-dimensional, do the same in both dimensions. For example, right and upward will be positive and left and downward will be negative. Next, pick the equation that only has one unknown in it. Note that you will need to know 3 variables to be able to calculate the other 2. If you have multiple stages with different accelerations, solve each one separately. Finally, remember that you need the number of equations to equal the number of unknowns, so choose accordingly. To best memorize the equations of motion and the problem-solving strategy, try to solve several different problems. Thank you for your attention and see you in the next video.